Hi, this is day 9. We're going to be talking about arc lengths on sector area. Today, figured I'd buy a pizza from Little Caesars and we could take some photos of that and use that. So let's start really quick with some basic vocabulary that we've done in the past. You all should know, for example, that's a diameter. And then we got radius. Ooh, that looks really nice. Radius. Doesn't look nice on white, but it looks nice on the pizza. Then we have a chord. There's a chord. I took my pizza cutter to it. So that would be an example of a chord. What else we got here? Diameter, radius, chord, tangent. Well, we can use sort of the edge of this box. So let's consider this box edge right here. It is tangent. There's not really a sector unless you want to call like the crease that's from me cutting the pizza. One more thing that we did cover though, we did talk about arcs. So we had a couple different kinds of arcs, so let's use the pizza crust for that. So that would be an example of an arc. In fact, it's a minor arc, whereas another slice of the pizza, or slices, if I go all the way, almost all the way around, that might be a major arc. Those are both arcs. So that's some basic vocabulary we've done in the past. Another thing we've done already is circumference and area. So I really like that yellow, so let's use that. So I measured the radius and took a picture of it. So let's look at that photo really quick. So over here, that edge of that is actually in the center. So it's looking like, let's say 16 centimeters is the radius. So let's write that down. So the radius equals 16 centimeters. And so if you recall, circumference equals 2r with a pi on the end, because we're going to still leave it in terms of pi. And area we're going to say is r squared pi at the end. So in this case, 2 times 16, or 32 pi centimeters. And then for the area, we have 16 squared pi. That is 256 pi square centimeters. So that is a review of some stuff that we've done in the past. So before I start talking about arc length again, and we did cover this already, but we're going to review it, let's also talk about sectors. So sector is the same thing as arc length, but instead of just talking about, I don't know why I'm using green here, that's sort of a gross thing to put on a pizza. Instead of using the distance around the circle, we're actually going to talk about the area of, like, say, a slice of pizza, and that would be the sector or the sector area. So we're going to use that phrase sector when we're describing a slice of a pizza. It's sort of triangular, but it's got that curvy arc on it, so it's not a triangle formula. It's a little bit different. The good news is we're going to be using the same math as we did for arc length. Now, I made the picture frame, the screen this large because I do want to steal the circumference and area answers we used in the past to do these problems. So for the arc length for this first set of problems, let me get rid of this green pizza. It's really making me nauseous. Let's maybe make it like caliente, really warm. So let's say we want to find half or a semicircle, the arc length of the semicircle. So if the circumference equals 32 pi, what do you think the arc length of the semicircle is going to be? Wouldn't it just be half? It would. And so it's just 16 pi. That's the answer. So that's an easy one. So if you see a circle and they give you such an easy number, like half of the circle, you can cheat, if you will, and sort of just eyeball it. You're not guessing, you're actually using math. Same thing with the area. The area is 256 pi, so the sector area would be half of that, which is 128 pi. Okay, so now this next picture, let's look at this part of the circle. What fraction of the circle would you think that is? I agree. I think it's 1/4 of the total pizza. So if I want to use that 1/4, it'd be 1/4 of 32 pi, which is a pi. That would be the arc length. And if I want to do the same thing for area, 1/4 of the total area would be, see, 4 goes into 25 6 times, 64 pi. There we go. So that is the basics of doing it if they give you nice fractions that you can work with. But we can do it with more irregular shapes as well. Okay, so I've split this pizza irregularly in the sense I took 3 slices and slid them away from the rest of the pizza. And so now it's not as easy of a fraction. I would not, if I were you, I would not just do, like, let's say there's 8 slices, say it's 3/8. Because as you know, if you share pizza with people, the slices are not equal to each other. So instead of doing that, we're going to use an angle measurement. So I went ahead and I threw a protractor on top of the pizza. And so we can actually look at that. I'm going to say it's 120, let's say it's 127 degrees. Okay. Remember, we have our radius of 16 centimeters that we're going to use. So those are the numbers that we're going to use for this. But while I'm here, since I'm looking at this, again, let's look at this carefully. If I do this really dark here, that is a minor arc, and that is a major arc. That's going to come into play. That's a major arc, and that's a minor. The minor is always less than half. The major is always bigger than half. If it's exactly half, we do not call it either one of those. We call it a semicircle. So let's talk about the arc length of the minor arc. So some things we need to know. We needed to know the radius is 16 centimeters. The angle out of 360 was 127 degrees. And with that, we should be able to find the arc length. Now we're talking about arc length. That is part of the circumference. Okay, so it would help to know what the circumference is. So let's do that part first. So part 1, C equals 2r, which is 16 pi. So we already figured out earlier that that was 32 pi. Part 2 is to find the arc length. So the arc length, AL, if you will, is going to be the fraction of that. So we're going to use 127 out of 360 and multiply it times 32 pi. So it looks really crazy, 127 times 32 divided by 360 with a pi on the end. But I use the Calculate 84 app that I suggested you download, and I have it on my phone. And so then I get this fraction, pi. So what you can do is you type it in, 127 times 32 divided by 360. You'll get a decimal, 11 point something. And then you can hit math. And the very first choice is to change it to a fraction. So math, enter, enter, and it will give you 508 over 45. So that is the answer for arc length. Moving on, let's talk about sector area, but we're going to do it for the major arc for this one. So the major arc is not 126 degrees, or what would it say? 127. The major arc is not the supplement. It's basically the other piece of 360. So the major arc is 360 minus 127. So 360 minus 127 is 233 degrees. So that's the angle we're going to use for the sector area. Now we're talking about sector area. So the first step is you need to figure out the area of the circle. Well, we did that already. If you scroll back, there it is, 256 pi. So 256 pi is the area of the circle. So if I want to figure out the sector area, I can use the angle out of 360 and multiply it by 256 pi. And again, I'm going to type that on my graphing calculator. So 233 times 256 divided by 360. I get 165 point whatever, 688 repeating. I go math, enter, enter, and I get 7,456 over 45 pi. Now, that's a crazy number, and it's square centimeters. But let's put this in this perspective. I actually changed that back into a decimal here. Math, clear that out. So let's go up to this, and I multiply that times pi. Where's my pi button? I've forgotten where. Oh, there it is, second pi. It's pi is above the, underneath the clear button. And I hit enter. So that's the same as 520.5 square centimeters. Now, that seems like a lot, especially when you look at the area. The area is 256 pi, but the area is 256 times pi, which is 804.25 centimeters squared. Now, these are rounded numbers, so I would rather we use the fraction that we have in our answer here. Go ahead and use this as your final answer. But we're starting to use a calculator now. Now it's it doesn't make sense to me to keep leaving in terms of pi, but it's sort of good practice. So we should keep doing it for the rest of this chapter. But just so you know, the major sector area is smaller than the total area. It just looks crazy when you have 7,456 over 45 times pi. But that's it. That is how to find sector area. And hopefully that makes sense to you. So if you're lucky, you have half of a circle or a quarter of a circle or 3/4 of a circle, then you can just use those fractions to find the partial area or partial arc length. But if you do have to figure out the arc length or the sector area of an angle, it's not impossible. You just resort back to our fractions and multiply that times the original total, and we should be fine. So hopefully that lesson made sense. Let's try some practice problems.